And I'm excited to be doing this. In the past, we've done in some conferences we've done two workshop or two sessions, one with on tree fruit and one with berry crops, and we've kind of merged them the past few years. So this is going to be a mix. We're going to kind of go back and forth, have presenters on both. I'm going to talk about heat stress. Later on, one of my colleagues will be talking about some heat stress work she's doing in raspberries, which is going to be really interesting. I'm looking forward to that. But I should also acknowledge this. A lot of this work was done by my graduate student, Josie Moon. And so I'm presenting this on behalf of her and myself. So a little bit about what we're looking at. And this is a type of drought stress or heat stress that you may or may not recognize right off the bat as being related to that, but it is. So there's some historical observations I want to start out with. So back in the 1970s, there was a drought in Washington, and they cut off the irrigation supply for a group of apple growers. And they did some really radical things to try and keep the trees alive. And they were able to, basically, for the last half of the season, there was no water. And so they completely were shut off. And so they did all these different radical things to try and keep the trees alive. And they did keep some of the trees alive. But the following year, some of the trees didn't produce any flowers, and others produced lots of doubled fruit. And this picture on the right is an example from a colleague at Colorado State showing a doubled apple. So it looks like little Siamese twins that are connected there together. And so that was related to severe drought stress the previous year. Another study was done in Texas where they looked at two different varieties of peaches. You can see their Harvester and Loring, and they treated them with, they either water stressed them or they kept them well irrigated. And then the next year they looked at the doubled ovaries. So the ovaries in the flower that had the little Siamese twins, and found that there was a lot higher incidence of doubling where they had drought stresses compared to where they didn't. So seems to be related to drought stress. They also saw with peaches that some years, instead of a full double, like you can see here on the bottom, where that's just the emerging fruit just after shuck split. But here in the middle, sometimes that results in what they call a deep suture, which means that the fruit isn't quite a double, but it's obviously not formed properly. So what does heat and drought stress look like? Well, this is an example. This is peaches and tart cherries, where you can see sometimes there's a full Siamese twin, like you can see with these peaches. Other times there'll be one side that's like small and it aborts, and so they call that a spur. In other cases, extreme, you can see here on the top right, you'll see triples. So that's one flower that should have resulted in one fruit, and it resulted in three fruitlets that are kind of fused together there. And that's a problem for tart cherries, particularly because they're processed and that won't go through the processing line. It causes all kinds of problems. The question is, though, when is this happening? Obviously, it's happening sometime during the year before. And so you kind of have to know a little bit more about the physiology of flowers and how they develop. So this is just showing the annual cycle of any kind of fruit, stone fruit or palm fruit. So we start here in the spring with bloom, then we have fruit set, then fruit growth through the season, and then harvest, and then we have a dormant period, and then bloom comes out the next year. Well, flower bud development is happening at the same time. So about the time of fruit set, in this example, we get sometime between here and during the growing season, we get bud initiation, and then the buds develop. Oops, sorry, go back. The buds develop over the fall and into the winter, and then they bloom the following year. So sometime during this previous year, some level of stress is causing malformed flower, which results in a malformed fruit. So bud initiation is when those first the sepals start to form, but then the pistil forms a little bit later. So we know from research on different crops that initiation phase, that phase where the meristem shifts gears and starts to produce, instead of leaf initials, it starts to produce sepals and petals. That in cherries, that's about 4 weeks after bloom from the previous year. In apples, it's 40 to 60 days after bloom. Peaches, it's about midsummer. But that's just that first initial initiation period where it's just the meristem shifts gears and starts to make a flower bud instead of a vegetative bud. We saw a situation in 2021 where we saw lots and lots of doubling in some orchards here in Utah. So tart cherry is our most important fruit crop, and growers were talking about seeing 10, 15, 20% of their fruit in some orchards looked like these pictures that I'm showing you. And they rejected the processing plant rejected some plantings just because the doubling was so high. And even in the ones where they accepted the crop, they saw a lot higher incidence of pits in the fruit, which is a sign that there's some doubles in there. So you can see 2019 and 2020, they had maybe 7-8%, and then it jumped up over 20%, even though they'd rejected some of their loads. So that kind of gives you an idea of how severe the problem was in 2021. So we got interested. The growers contacted us and wanted us to look at some of these things. So we started looking at some of the work that's been done in sweet cherries. And this is from Washington. Tim Smith was an extension specialist there, and he had looked at some different blocks on the same farm that had been irrigated differently and handled differently. And this is in sweet cherries again. But they found that if they had a drip irrigated orchard with no ground cover, so just bare ground underneath, and the ground was dry, that they saw 24% of 24% of the fruit was either fully doubled or the spurs, like I talked about before, which is shown in this picture in the middle here. If they ran under tree sprinklers and had ground cover between the trees so that would tend to cool the orchard down some, they saw 12% doubling. And then they did another treatment where they put over tree sprinklers and turn the sprinklers on every time the temperature was above about 90 degrees to try and evaporatively cool. They did that through the whole summer. And by running the sprinklers every time the temperature got above 90, they cut the doubling incidence down to about 3%. So they found out, for one thing, that the evaporative cooling was good, but does it required to do it all season? That's a lot of water. In Utah, we wouldn't be able to do that, most of us, because we just don't have the water that would allow us to evaporatively cool our trees through the whole summer. So another scientist at Washington State picked this up, Matt Whiting, and he looked at Bing and Tieton, two different sweet cherry cultivars, and he looked at the timing of cooling and heating and what the temperature threshold was and when that critical time was, to trying to develop some strategies for reducing doubling in the field. And the way he went about this is he built this basically a portable HVAC machine that would either heat the air or cool the air and then blow either the heated or cooled air onto a set of spurs on the cherry tree. So you can see this machine is part of it's pumping out hot air, part of it's pumping out cooled air. And then they've got tubes going out and they're positioning at different spurs. And then they do it for a couple of weeks and then move it to a separate set of buds for a few weeks, and did that through the season over several years. And basically so one side of the machine is heating the air 9 degrees above whatever the air temperature, the natural air temperature is. The other side is doing 9 degrees cooler than what the air is. And they did this over a couple of years and found that the susceptibility varies by season. And it doesn't seem to happen from heating them up in June or early July, but if they heat them up in July and from late July to early September, they increased the numbers of doubles. But one of the things they found was that in the years where there was less susceptibility, it seemed that it was hot early on. So those buds had somehow been exposed to hotter temperatures early in the season than they had been in the later. So the next year they went and did where they heated them in June, late June, early July, and then either cooled or heated them in late July, early August. And if they heated them up in late June, early July, and then cooled them down or heated them again later on, they got no doubling. If they gave them cool temperatures in the spring, so they didn't expose them to any heat early on, and in fact cooled them down, then they saw that if they cooled them early and then cooled them again late, they didn't get any double. If they cooled them early, again, late June, early July, and then they had heated them up in late July, August, they got 25% of the cherries were doubles. So we looked at this situation and said, how does this compare to what we saw in 2020 in Utah? So we saw the doubling in 2021. We went back to the temperatures in 2020. Here's the period where they cooled them down in Washington for again, this is sweet cherries, not tart cherries. And here's where they heated them up. And you can see we had cooler than normal conditions. So the blue is the average, a running 6-year average. The red is that 2020 season. So it got cooler than normal. This is the daytime high was 65 degrees, 66 degrees, which is much cooler than normal for that period of time. And then if we look at that late July, early August, we had 3 days in a row that were over 100, about 103 degrees. And generally from there through the end of into late August, it was much hotter than normal. So that was the year that we saw the doubling. So one thing also that I want to mention about this, we did some work a number of years ago with tart cherries and looking at the effect of drought stress on leaf and bud temperature. And so this is the level of drought stress. The farther to the right, the more drought stressed, the farther to the right, the more well watered. And then to the left is the drought stressed. And what this shows is that the temperature, when we're well watered, when the trees have all the water they want, the temperatures are 7 degrees cooler than the air temperature. So this is air temperature, and this is the difference. And this is in Celsius. I put it in Fahrenheit here. So if the trees are well watered, the leaves and buds are about 7 degrees colder than the air temperature. So that evaporative cooling is happening naturally. But when the trees become drought stressed, then that temperature gets to about 2 degrees above air temperature. So again, that week that we were talking about the previous year, 103 degrees, if those trees happen to be drought stressed instead of well watered, then those buds would have been 105 as opposed to 95. So you can see how the water status can come into that as well. So with tart cherries, we wanted to see really what the timing was, what the critical temperatures were, and what we could do to alleviate those conditions. And so that's the study that my student Josie's been working on over the past 3 years. And I'm going to give a little bit of the results there. So what we wanted to do, instead of building an HVAC machine, we wanted to figure out another way we could just heat stress a whole tree. And the way we did this, we built these structures, these portable structures that we could put either plastic on. This is just greenhouse grade plastic, or shade cloth. And then we could put this over a tree so it enclose an entire tree for a week, and then open the ends up and slide it down to another tree and expose them at 1 week intervals through the season and see where we got the doubling. And then we wanted to compare that to a tree that we shaded. And then also some trees, we had trees set aside that we didn't do either the heating or either the plastic or the shade cloth. And so we did that in 2022. We treated them both ways and then monitored them through harvest in 2023. Then we set up another experiment in 2023 where we treated them, and then we monitored them in 2024. In looking at the doubling, we divided the tree into quadrants. We looked at the trees run, or the rows run north and south. And we looked at the east side of the tree versus the west side of the tree. And then we divided it into the top, the middle, and the bottom. And then we go in before harvest and look at fruit and see what kind of fraction. We did 100 in each section on each tree and said, okay, how many doubles are we getting in 100 in these locations? And when we looked, so we basically 6 locations per tree, and then we had trees treated at different times of the year. And then at harvest, in addition to looking at 100 in each section during that period, we also machine harvested the trees and then went through the harvest bin and pulled out 600 fruit randomly from the bin, and then counted the number of doubles in that 600 fruit sample from each tree. So this is what the results look like averaged over the various heated treatments. So if you look, and this is just to show you kind of the positional effect in the tree. So the top east and west are here. You see 4.5% of the fruit are doubles on the east top versus 5.5% on the west top. And again, this is just averaging over all the trees. And then if you look in the middle, it's 5% on the west side and 2.5% on the east side. And then in the bottom, it's lower, but it's always more on the west side than on the east side, which correlates with the temperature heat stress hypothesis, in that the west side of the tree, because it has that afternoon sun, is always warmer than the east side of the tree. And so it's giving you more of that heat stress response. If we look, so there's the east and west again for the top, just comparing that. And then that shows the west side versus the arrows are showing you the west side versus the east side. If we break that out by when we gave them the heat stress, when we put the plastic cover on them versus when we put shade over them versus the control. So the one that didn't get any covering was the control, that's in green. And it showed about 3% of the fruit were doubled on that one. And then this is 1 week before harvest, 1 week after harvest, 2, 3, 4, out through 9 weeks after harvest. Harvest is usually about the middle of July. So we use that as a reference point. Is it before or after harvest? And you can see we had, in some cases, 10, 12% of the fruit were doubled. We did that again the next year. We didn't see nearly as much doubling the next year. And surprisingly, a little bit, initially surprising, we didn't see, there's a fair number of doubles even under the shade cloth. And I'll talk a little bit more about why that would be the case. But just focusing in on the plastic treatment where we really heat stress these things, basically put them in an unventilated greenhouse for a week at different stages, you can see the doubling over the 2 years. And again, it was very different between the 2 years. But here in the first year where we had 10, 12%, it seemed to peak at about between 4 and 6 weeks after harvest was when we really induced a lot of doubles. So that seems to be a pretty critical period. And the next year we did see some doubling early on, but again, we saw a peak at about 5 weeks after harvest. The harvest season was just a little bit different between the 2 years. So those, if you look at the actual dates, they don't quite line up. 5 weeks after harvest in year one was August 19th versus August 25th the other year. But both years, that 5 weeks after harvest seems to be when we get the most doubles. So why so much more in 2023 than 2024? Well, we look at the temperature. Here's again going back to 2020. There's what the Washington folks said in sweet cherries would induce it, this cool weather in late June, early July, and hot weather in July and August. So that was 2020 when we saw all the doubling that we saw. But if you look, anytime pre-harvest was hotter than or cooler than normal. We had a number of periods where it was quite a bit cooler than normal. This is again the daytime high temperature for that date. And so it never got above 60, 65 degrees on several periods during that pre-harvest period between, say, bloom and that period that the Washington group found. And then if you look post-harvest, that whole period was a lot hotter than normal. This is what it looked like in 2022 when we tried to induce a lot of heating and a lot of doubling and those same periods. So we didn't see really, really hot temperatures at Kaysville outside. We didn't see the 102, 103 degrees during that period, late July, early August. And it wasn't a whole lot cooler, but we were still able to induce some doubling. Now we did see some cooler temperatures earlier on. And if you look at that 3 to 5, so there's our harvest window. And that 3 to 5 weeks afterwards, we had some temperatures that were close to 100 degrees, not 103, 104, but we did see some hot temperatures. So that's the year that we were able to induce more doubling at our farm at Kaysville. And again, during that 30 days after harvest, it was hotter than normal. The next year where we saw less doubling, if you zero in on those, we did see a little bit of heat, but in general, this is that July 25th to August 10th. But if you look, we didn't see quite as cold temperatures. It was a little closer to normal early on. And we didn't see that, the 30 days or beyond 30 days, we didn't see super hot temperatures outside. So that would probably explain why we saw less doubling in that 2023 season than we did, or the 2024 season than we did in the 2023 season. So, what are we taking from this? Well, how do we minimize doubling? We kind of know now when that critical period is for tart cherries. It seems to be 3 to 5 weeks after harvest. And so can we do some management strategies during that period of time if we've got hot weather in the forecast? Could we use evaporative cooling? This is rather than running, so the Washington group ran sprinklers over the top of the whole orchard. We've been doing some experiments. This is a fan that's used for frost protection, but it also allows for evaporative cooling. It's got some mist nozzles. So this last year we ran the sprinkler, or ran the misting and ran the fan to try and cool the tops of those trees where we're getting a lot of the doubling. We don't yet have the results for that. We're waiting on the data. We didn't see, like I mentioned before, we didn't see where a single tree, putting shade cloth over a single tree really helped a whole lot. It's obviously a little less than putting plastic over it. I think what was going on here is when you enclose that tree in shade cloth, you basically cut down air currents and it still gets warm in there, warmer than it, not as hot as it did under the plastic by any means, but it didn't cool it as much as one would expect because it was essentially enclosed. So I think if you put shade cloth over a bigger area and it was more open to circulation, you wouldn't see the same level of doubling that we saw. So one other thing that we've been considering, and we didn't put these trials out this last year, but we've been looking at this, is what's called spray on shade. So this is, there's two different products that do this. You're basically whitewashing the tree. This is a pear orchard where they were comparing it. I found this picture and it illustrates what goes on here. But there's two different products. One's called Surround. It's basically colloidal clay solution that you can spray on, and it basically coats the tree with white clay, which eventually washes off, but it's non-toxic. It's just clay particles, and it cools that, basically cools that tree. There's another one that we've gotten a hold of, we're going to test as well. It's basically a calcium carbonate. You're putting hard water deposits on your plant to shade it. And the reason we're interested in this, there's a group in Europe that did a comparison, and they looked at, and I've got the table down here at the bottom. They've got an untreated control, shade cloth like we used, only covering, instead of enclosing the tree, it's over the top, so there's some cross ventilation there. The kaolin, which is that spray on shading, fogging, which we tried, and then combinations. And what's interesting to me here is if you look at the control and the kaolin treated, the spray on shading, it worked. This, you see the kaolin 0.77% doubles in this particular variety versus 6.5% in the control. It worked about as well as anything, and without lots of infrastructure to put up shade cloth or without the water requirement. It actually worked better than fogging alone for most of these. So we're really encouraged by this, and this is something we're going to continue to test. But what I think the recommendations that we can say is that heat stress, at least for tart cherries, that 4 to 6 weeks after harvest is really the critical time when you're going to get doubles. You can see this in this picture right here. You can see here's the flower, and there's actually 2 fused pistils. This is going to turn into one of these Siamese twin fruits. So keeping water and heat stress at a minimum during that 4 to 6 weeks after harvest is probably your best bet. So in 2022, based on our harvest season, that was August 12th to September 1st, and the next year it was about a week later. That seems to be the critical period. The bottom line takeaway, I think, is that we need to be, excuse me, we need to be more careful about how we treat stone fruits, in particular after harvest. Sometimes we take the fruit off and we don't tend to think about what's going on with the plant. And that's a really critical stage of development when the flower buds are forming for next year. And if we mess it up at that point, we're going to impact our crop the next year. I think that's really the main take-home message that I want to make there. And I'm probably near the end of my time. In fact, I am. So I'm going to pause there and stop sharing my screen and see if there's any questions that I need to answer.
Yeah, we just have one question. One question. So, oh, we got a couple coming in. So if you have questions, stick them in the Q&A. So thank you. So Brent, first question that we had for you is from Becky. She's asking, how does the clay fogging affect photosynthesis?
Yeah, so that's a great question. And the answer is not as much as you would think. So typically with apples and peaches and cherries, we only need about the maximum light we need for maximum photosynthesis ends up kind of saturating at about 800 to 900 micro Einsteins. And in the case of a Utah, nice sunny day in Utah, we get like 2000. So if we're knocking out 30, 40% during that peak heat stress period, then we're not diminishing photosynthesis as much as we are just decreasing the heat load on that plant, if that makes sense. We're still well into saturation range, but we're preventing the kind of heat load and heat stress that can cause problems the next year.
Okay, so another question. There's a couple more, but I'll skip around a little bit. Would the same 4 to 6 week post-harvest timeline be expected to have the same results for backyard sweet cherry growers?
So that's an interesting one. So the 4 to 6 weeks for sweet cherries is that they harvest a lot earlier than tart cherries. So it may be a little bit farther post-harvest, but I would say, I mean, I think based on what we're seeing, that late July, early August is going to be, that's depending on where you are, that's maybe on the later window of that 6 weeks. But if you're looking at, if they're calling for 100-degree plus weather, the first thing you need to do is keep the tree well watered, keep it from going into drought stress. The second thing is if we're into that period, then spray on shade, maybe running overhead sprinklers, any of those things. I saw the question pop up, where do you get kaolin clay? So that's the product is called Surround. I put that in one of my slides. That's one product, the Surround, and then the other one that you can get, I don't know if anybody in Utah is selling that right now. The other one that I mentioned, I believe, was called Diffusion. And that's one that, yeah, it's Diffusion. That one, there are places locally that are selling that. That's the calcium carbonate.
Any recommendations on applying it on a home tree and a home site?
Yeah, so the trick is you're going to have to get good coverage. And I would say rather than getting good coverage over the whole tree, you might climb up on a ladder and spray it across the top because that's where the heat load is. It's those upper branches and those upper leaves that's going to give you the best benefit in terms of shading that plant.